Okay, so today we're doing and formula. Okay, now I know you're going to say we did the and formula the other day, and the and formula was the probability of A and B equals the probability of B times the probability of A given B. Okay, that's the and formula for conditional. Okay, something's conditional that it happened. Okay, as in one thing affects the next thing. But we also have and as a independent. Okay, and that's where we have more than one independent event occurring. And that'd be the probability of A and B occurring would equal the probability of A times the probability of B. Okay, so we're going to work through these two as we go through. Let's work with independent one first. So an example of independent would be a question such as, what's the probability of, let's say we flip a heads on a coin and select a club from a deck of cards. Okay. Now these are independent because the flipping of a coin does not affect the club from the deck of cards. So the probability, so we're looking at the probability of a head and a club. And that would equal the probability of flipping a heads times the probability of selecting a club. So the probability of getting heads on a coin would be 1 over 2. The probability of picking a club would be 1 over 4. Now, hypothetically, that would also, the 1 over 4 is 13 over 52. So then we multiply those two together, it'd be 1 out of 8 chance that if I flipped a coin and picked a card, it would be, I'd be successful. So 1 out of 8. Okay. Now, what if I did something like, what's the probability? Let's say a family's having 3 kids. Or let's do this one. What's the probability of, let's say there's 3 questions on a test. Okay. They're multiple choice with 4 possible answers. With 1 correct answer. So 1 correct answer. So what's the probability I get all 3 correct? So that'd be probability of getting correct 1 and correct 2 and correct 3. Well, the probability would be, let's see here, that'd be probability of correct 1 times the probability of correct 2 times the probability of correct 3. So that would equal, well, the probability of getting an answer right, if I'm just guessing, would be 1 out of 4 times 1 out of 4 times 1 out of 4. So probability of getting all 3 right would be 1 out of 16. I believe I'm looking at 64. 4 to the power of 3 is 64. Correct. 64. Okay. So those are all independent. Okay. So one does not, picking an answer for question 1 does not affect the probability of question 2 occurring and probability of question 3 occurring. Okay. So let's go back here and I'm going to switch to here we go. Here's the actual formula written out. I wrote it up there. So probability of A and B is probability of A times probability of B, but A and B have to be independent. So, oops, that's what I want. So let's look here. We'll do it independently. We'll do it using the formula, and then we'll double check it. So you roll a red dice. I'm going to change that from red to blue. Okay, your green dice and red dice. So we're going to roll a green dice, and we're going to roll a blue dice. What's the probability of getting a 4 on a green and a 3 in a blue? Now, when I roll those dice, one dice is not going to affect the other dice. So if you think about it, the probability of getting a green 4 and a blue 3 equals the probability of getting a green 4 times the probability of getting a blue 3. So realistically, the probability of getting a 4 is 1 out of 6 on a dice. Probability of getting a 3 on it is 1 out of 6. So if we multiply those, it's going to be 1 out of 36. Now if we go over here and look at our dice, probability of getting a green 4 would be a green 4, my 4 is here, is all these ones. Now the probability of getting a blue 3 are all these ones. And the probability of getting both of them is right here. There's only one where they cross over. So it's 1 out of 36. There's 36 possible answers there. Okay, so copy that. Paste it and bring it in. Now let's do the second one. The second one says a green 2 and a sum of 3. Okay. So those are independent because like me rolling a green 2 is not going to affect the probability of getting a sum of 3. Okay, they're both independent. So we can go ahead and do this again. So what's the probability of rolling a green 2 and a sum of 3? So that's going to be the probability of a green 2 times the probability of a sum of 3. Now green 2, getting a 2 on a dice is 1 out of 6. Now if we look over here, a sum of 3, if we're looking for sum of 3, there's 2 sums of 3s. So it's going to be 2 over 36 possible outcomes. Right? Which also equals 1 over 18. Let's go 2 over 36. So we multiply those together. So we're going to do 2 over, I don't like the way it's looking, a green 2 and a sum of 3. It's going to be way too big off the top of my head. 1 over 6 times 1 over 18. 1 and 108. That doesn't make sense at all. Why does that make sense? Let's do this over. So a green 2 is right here. A sum of 3 is going to be right here and right here. So there should be 1 out of it should be 1 out of 36 chance. That should be the answer. I'll go back and look over that. Okay. All right. So let's take a look at this one. Okay, a bag contains 1 red marble and 2 blue marbles. So we have 1 red marble and 2 blue marbles. What's the probability of a blue marble being done both times? But the key here is we're going to replace the marble after each choosing. Okay. So since we're replacing it, it's going to be independent. So we're looking for 2 blue marbles. So it's independent. So probably getting a blue 1 and a blue 2 equals the probability of blue 1 times the probability of blue 2. So that's blue 1 getting a blue 1 the first time is going to be 2 over 3. Now hypothetically we're going to take that away, but we're going to replace it. So it turns out that's going to be the exact same probability the second time, which would be 4 over 9. So that's the probability of getting it back to back if we replace it. Now, if we don't replace it, it's going to be a little different. That's going to be a dependent one. So we're looking at probability of getting blue 1 and a blue 2. Okay, so the probability of getting a blue 2 given I got blue 1 the first time times the probability of getting a blue 1. So I'm going to start over here. What's the probability of getting a blue the first time? It's 2 over 3. So we're going to pretend we took that one away. Then the second time we pull, what's the probability of getting a blue the second time given we got a blue the first time? Well, it's going to be a half because there's only 2 left and one where they're blue. So the final answer there is going to be 2 over 6. All right? So what's the probability of selecting exactly one white, let's go blue marble, with no replacement when 2 marbles are drawn? So we have 2, 2, and 1. Now we have to realize that getting exactly one blue marble can happen 2 different ways. I could select the blue one first, then a red one, or I could select a red one, then a blue one. Okay? So this is going to be dependent, right? Since the first draw depends, second draw depends on what happens the first draw. So the first probability is going to be, we want the blue one first, a blue 1 and a red 2. So that's going to equal the probability of getting a red 2 given I got a blue the first time times the probability, now this is here in the second spot, it's probability of getting a blue the first time. So probability of getting blue the first time is 2 out of 3. And then the probability of getting, now if I had 2 here, let's say I had 2 here, right? I get rid of that one. Now the probability of getting a red is going to be 1 out of 2. So for this first one, my probability is going to be 2 out of 6. Now if I want to go red 1, blue 2, that's going to be probability of getting a blue second and a red first. I like to do my given first. It's going to be a blue the second time given I got a red the first time times the probability of getting a red the first time. So that's going to be, probability of getting a red the first time is 1 out of 3. Let's say we had this and we got rid of the red one first. The probability of getting a blue the second time given I got a red the first time is going to be a 2 out of 2 shot, which equals 2 over 6 again. If we add those together, we would get 4 out of 6 chances. So we go 2 over 6 plus 2 over 6. But you go 4 out of 6 chances, we would get a blue and 1 blue, 1 red. Okay? So you have a bag of M&Ms. There are 6 orange, 4 green, 5 red, 3 brown, 3 yellow, and 4 blue. What's the probability of selecting 1 blue, then 1 red without replacement? So I'm looking at, now this is going to be dependent because it's without replacement. So what's the probability of getting a blue one first, then a red one second? So that's going to be the probability of getting a blue one. A red one second, given I got a blue one first, times the probability of getting a blue the first time. So the probability of getting a blue one, there are 4 blue, And I believe there's 25 altogether. 6, that's 10, 15, 18, 21, 25. So there's a 4 in 25 chance of getting the blue one with my first pull. Now, the probability of getting me a red one the second one, given I got a blue one the first time, well, there's only 24 left in the bin because I took one out, and there's 5 red ones. So that's going to be 20 over 24 times 25, 600. I believe one of my kids said it was 130. 20, oops. 130 or a 0.033 or a 3.3% chance of that happening. Okay, so the big thing is when you're looking at the and, you have to figure out if it's independent or dependent and use the proper formula.